Yeah. Super, sir.
Sir, am I audible?
Yes, sir. Now only.
Yeah.
Let me start the session, sir.
Yeah. Okay, sir.
Yes, sir. Uh, Dear participants, formal chief guest introduction. Here, Dr. Sukumar Nallappan Challappan is the professor of the University Nusaputra, West Java, Indonesia. He has completed bachelor's in mechanical engineering, master's in production, industrial robotics engineering in 2019 at PSG College of Technology, and he has awarded PhD in aerospace materials in Anna University, Chennai. He has vast years of working experience in international university across Asia, Europe, and Gulf countries. Also, he had broad visionary of global collaborations for faculty students exchange internships and research activities. He also advised for global university industries for curriculum development and consultancy activities. Subject expertise and structural dynamics, vibration, automotive design, and thermodynamics. He has published more than 40 articles, books, and patents in reputed international journals and conferences. His areas of research interests include composite materials, IoT design, sustainable materials, natural fibers, fluid transportation, and biomass energy conservation, etc. So I hope that our resource person is suitable for this our title. Now I invite Professor N.S. Okumar. The session is yours, sir. Thank you.
Yeah. Thank you. Thank you, Manivel sir, for your nice introduction. So I'll just, is it audible, sir? My
Yes, sir.
voice
Yes,
is
sir.
okay? Yeah.
Yes.
Just I'll open share my presentation. Okay, sir. My screen visible?
Sir, please change presentation mode, sir.
Yeah. Now, okay, sir.
It is not changed. Just move on the next slide, sir. We'll see. Or
Next
press
slide.
F5. Press F5.
Changing, sir. Slide changing.
No, sir. No.
No.
Put it presentation mode, sir. Slide change it now.
Yeah.
Press F5.
Just I open in the presentation in Google Meet. Wait, sir. Okay, I repeat it once again. Now it is visible, sir.
No, sir. Please share the slides. Slides not shared.
Okay. Okay, sir. Is it visible now?
Now only is presenting, sir.
Okay. Yeah. Yeah, it's full screen, right, sir? Now, slide changing.
No, sir. Off screens only is visible.
Oh. Again, same, sir. Not full screen.
Yes, sir. Or you can start the session, sir.
Oh, if it is not visible, means how, sir? Is it again? I
So
will
screen is not visible. You will zoom out, sir.
zoom out.
Zoom out பண்ணுங்க சரியா போயிடும்.
Wait, sir, and once again I do. I will open entire screen.
So
Okay,
while
I
sharing
think
the
you can
screen, you
see
give
now.
entire. While sharing the screen,
Yeah,
you
yeah,
give entire screen sharing.
yeah, yeah. Now it is okay, sir.
Now you put it in the presentation mode.
Yeah,
Hmm.
yeah.
Okay,
Yes,
and
sir.
now it is.
Now it's okay.
Okay.
Okay,
Yes, sir.
yeah. Okay. Okay. So once again, I thank you, Dr. Manivel sir and Prakash sir, for giving me this opportunity. And I formally thank our NPR principal, Dr. P. Maradakannan sir, principal, and our university, Nusaputra University, Dr. Kurniavan, rector, and Dr. Hangi Parthiva is vice rector of Nusaputra University, and Teddy, dean of engineering and management. And again, I will once again I thank AICTE Atal team for giving me this wonderful opportunity. Now today, I'm going to start my session. Today, my session is about recent trends in biocomposite research. Just I'm giving the insight of my experimental research on recent research on biocomposite materials. So these are all my topics today I'm going to cover. I'm mainly focusing on biomass composites and how it is introduced to engineering application and different testing methodology and manufacturing techniques I'm going to cover in this whole session. And also I have some experimental results and some validation part using SEM images, and also have some future scope work regarding the composite biocomposite materials for your future research. We can carry out such kind of research in next step. And the composite materials are widely used nowadays, especially in engineering field and medical field, and almost all conventional materials are changing to composite materials, especially the sustainable composite materials are evolving nowadays because of the cost effectiveness and the environment friendly materials. So these are the main focus on this kind of researches nowadays. And also many bodies, they are encouraging to do such kind of researches which are not involving any environmental pollution effect, and as well as to reduce the chemical reactions while doing the process or operations. And here, as we know very well, the composite is mainly used for to reduce the weight and increasing the strength of the material, whereas in conventional material it is not possible for certain extent. So we are nowadays slowly moving to non-conventional material like composites, especially metal matrix composites and nano composites and carbon fiber reinforced composites, and this biodegradable, using biodegradable material they're using for increasing the strength as well as to disposing after the life period of the component. The disposal is one of the another criteria. One of the important problem is waste management system all over the world. So using the waste materials, so they are planning to do some useful innovative materials by means of uh, natural process technique, not involving too much of chemical reactions. So such kind of processes takes more environment friendly and uh, not affecting this environment. So they are mainly focusing nowadays bio materials as a polymer and biomaterials as a reinforcement certain extent. And you know very well, many aircraft applications and many engineering components nowadays they keep on slowly changing to from conventional material to non-conventional material like composite. The best example is aircraft. Almost structural part of the aircraft like wings, landing gear, or some kind of internal interior and fuselage, all those things they made by the composite materials instead of conventional materials because of its increased strength and lighter weight, and also it is more fuel economy of aircraft, and improved performance of the aircraft. So this all we all know very well about such kind of performance as mechanical point of view. And moreover, so here I have given such kind of literature review before I am going to introduce my research part in this session. I have taken study from different aspect. One is the polymer matrix composites, and another is uh, role of betel nut fiber composites, how fiber is changing the material characteristics, and why you want to use chitin particle to the polymer, how it is improving the quality of the composite material by introducing chitin, and why uh, hybrid composites are important in order to managing or in order to cope up different multiple tasking materials without compromising any mechanical properties. I have I have given some literature here, especially in terms of natural fiber in polymer matrix composites. One is here the first study, the impact of mechanical and thermal impact properties of varying weight percentage of cellulose fiber. Cellulose is very natural fiber material. It is the base of bio composite is the beginning. Now they're using different materials in place of the same characteristics of chemical characteristics of cellulose, like chitin, and they sometimes they're using leather also. And there are many significant observations I have found from this kind of literature. And This is about betel nut and natural fiber study. How there are many natural fibers, as we know very well. It's a bamboo and banana leaf and other many natural fibers are available. Hemp. So in this my study is mainly it is about how to introduce a betel nut, because it is not significantly used in many researchers. So I have chosen as a betel nut or the it is like a chute. It is like a chute. They making as a fiber threads, and they processed cured by certain temperature and making as a laminate and incorporating with the uh, polymer matrix. And also it is a continuation of that whole literature only. I'm not going to cover too much about this literature. I go to directly my work. So these all I studied how the polymer is enhancing the property of the composites, and how why the hybrid composite is nothing but a more than two fiber material or more than two different types of matrix. If you are using, that is called hybrid composites. I am here using different kind of fibers reinforcement. I used two types of reinforcement I used here. One is the leather, that is waste leather, and the second one is um, betel nut. Betel nut is another fiber material. I used as a laminate here with the use of epoxy resin. So resin or matrix material is I used here is e-glass epoxy. These are all my literature. So finally, I concluded my literature here is the various studies I have gone through from different authors, and I observed that there are many researchers that they used only different kind of corn, banana, and sisal, kevlar, and kenaf. So they are not touching too much of uh, this kind of betel nut fiber and leather. So I have chosen as goat leather and betel nut for my work. In addition to improving the bonding strength, I have used here chitin based epoxy composites, and I have made different kind of specimens for testing by using Ceylon treated and non Ceylon treated. So as usual, I made a conventional method by using hand layup technique. I made a epoxy resin, and I used goat leather and betel nut stacking one by one. Then I made one set of non-treated, and another one set is treated by Ceylon. So this is my literature gap I found. Chitosan and other biofillers are in the natural fiber industry has been widely documented by researchers. The use of leather as an energy absorber in composites is not yet investigated soundly. So, no research had been done on leather and betel nut fibers. It is there is research, but not a significant amount. So I have, in addition, the effect of Ceylon treated and leather based composite against external load have not been studied. So because after applying mechanical loading, how the mechanical properties are uh, improving. So that is not studied too much in the previous researchers. So I have considered as mechanical testing and as well as fatigue testing. and machining testing also I have considered in my study. So after completing this, I have analyzed different mechanical properties like interlaminar shear stress, wear, friction, and low velocity impact damage analysis, and fatigue life cycle, fracture analysis or fracture toughness, and drilling characteristics. It is kind of machining characters. So my objective here is to make composite material by using ordinary method called very familiar method, etc. Fan layup technique, by using waste goat leather and betel nut fiber and chitin toughened epoxy composite. So chitin toughened epoxy is using for to enhancing the bonding strength of the betel nut fiber and leather. And the second one is to prepare as received specimen. I have designated as FLF0, FLF1, FLF2. And there is one more specimen, just it is a pure epoxy material. So for the reference, I have chosen as a comparison, I have made pure epoxy also as a specimen. Investigate the adhesion improvement between the fiber and leather within the resin in the composite. And another investigation is to integrate mechanical properties of treated and non-treated. Using Ceylon treated and non-Ceylon treated, I have chosen two different category. And to study the tribological behavior like wear using pin on disc and some other frictional characteristics I have analyzed. Investigate machining properties of both received and Ceylon treated. As received is nothing but a ordinary specimen, and treated is nothing but a Ceylon treated specimen. Okay, so this is my methodology. Mainly I am focusing here is there are 4 specimen. This is 100% epoxy, and the second one is 70% epoxy, 69.5, 68, and remaining all betel nut and goat leather percentage, volume percentage I have chosen here. And CBP is nothing but a chitin based polymer. So they have added chitin 0.5 percentage and 1 percentage for the last specimen. And there are two kind of specimen as I mentioned previously. One is treated and another is non-treated. Treated means Ceylon treated. By Ceylon is nothing but they're adding water with the Ceylon chemical and dip into this chemical for 10 minutes. And here I have testings are like mechanical testing, tribological testing, and machining properties. In my mechanical testing, I have done tensile, flexural, ISOD, drop load impact, and harness. ILSS means it is interlaminar shear strength. How the laminates are withstanding the forces in each and every laminates. So that is interlaminar shear strength and fatigue strength, fracture toughness. And using tribological testing, I have conducted wear rate and coefficient of friction, and SEM analysis also done. And machining, I have only did two parameter. One is surface roughness and roundness, because it is not a metal based composites. So I am not focusing to many in the machining aspect. So here, the materials I used here, the matrix material is epoxy resin. As we are familiar in this resin, almost we are using epoxy resin in all polymer based composites. And I used chitin filler as a matrix mixer. So in addition with this epoxy resin, I used chitin filler, 1% and 0.5% for different specimen type. So these are the pictures I have shown. I wanted to show you to you. And just it is a betel nut. We call it as Pak Kotai in Tamil. So they used the same one, and they have make it as a fiber by using techniques, and it has a density of 0.9 average, 0.9 gram per centimeter cube. And the goat leather thickness is little more than fiber, so it is 1.1 gram per centimeter cube. So why I chosen goat leather is it is more uh, more comfort, softer than cow leather. So probably goat leather I have chosen. In future research, you can select cow leather also to see how the differences are in goat leather and cow leather. And here, chemically treated solvent is nothing but a Ceylon. I used the Ceylon is some kind of chemical. I mentioned here the chemical properties of the solvent. Ceylon treatment is advantageous to composite because it enhances their adhesion property and loading sharing phenomena. It has more bonding strength between leather and epoxy resin, and as well as got betel nut fiber. And this is the procedure how I used to Ceylon treatment means I used aqua solution approach. So I have added 3% of Ceylon with the water, 3% weight percentage. So with water. So and after that I used natural fiber mats and betel nut mats with 10 minutes immersed in that chemical. And finally, I treated with after treatment of chemical treatment using Ceylon, I used 110 degrees Celsius. I cured the panels, leather as well as betel nut. And these are my designation of the composites. The first one is pure epoxy, 100%. So to check how the difference of mechanical properties. So and also the second one is FL-F0 is designated nothing but a 70% epoxy and only fiber leather, no CBP particles. It is very normal method, 70-30. And third one is FL-FN1 is nothing but 69.5 is epoxy and 30% is nothing but leather and fiber. Fiber means um, uh, areca nut only. Areca nut as well as betel nut, both are same. Areca, sometimes I used the designation called areca nut. Areca nut and betel nut both are same meaning. And the fourth one is FLF2, 68% of epoxy, and actually this is 69, not 68. This is a typing mistake. 69 percentage and 30 percentage of fiber leather and 1% of CBP. Now, this fabrication composite laminates by using hand lathe, and two types I created. One is as received condition and Ceylon treated condition. Okay. Then and epoxy was mixed with 30%, 30 minutes with CBP particles containing 0.5 and 1% volume for the last two specimen, that is FLF0, sorry, FLF1, FLF2. And the molds of correct dimensions by using silicon, as well as you can use normal wood also. Then I after completing the fabrication process, I cured 120 degrees Celsius for 48 hours post curing method. The epoxy composites after that had been cured room temperature. So this is the cured one, leather and fiber and chitin. So this is after fabrication. And these are all my prepared testing specimen. I had many testing as I mentioned in the methodology. Test. This is tensile specimen. It is a flexural specimen. Impact and hardness, wear ILSS, fatigue specimen and fracture toughness, drop load specimens. So why drop load specimens are here means it is a unique kind of testing. They keeping some distance, they dropping some amount of weight to certain velocity. How much load it same like impact. It same like impact only, but by using different velocity, they're testing. It is called drop load testing. Here I am representing the ASTM standards for different specimens. Tensile specimen I used for polymer composites ASTM-D 3030 and 790 for flexural specimen, and interlaminar shear strength for 2344. So these are the designation of ASTM. And other specimen is here. I used ASTM-D for T256 for impact, ISOD impact test specimen, and ASTM-D2240 for hardness. So I used Shore D hardness testing. And here the tribological properties specimens I have mentioned here. The ISTM standard is G99, specifies for rear wear specimen. I used pin on disc method and a load of 5 Newton and a sliding speed of 800 RPM and a sliding distance of 400 meter. So the disc capacity have 180 mm diameter. And the flat specimen 3 mm thickness and 5 mm wide is used for measure wear resistance of composites. And drop load impact also I used. There is no certain specific ASTM standard. So I used a normal size of 2.5 centimeter semicircular pendulum dropper. And there are it is about fatigue property, time dependent behavior. It is the model of fatigue specimen and it is for fracture toughness. I used this machine for SEM analysis. And I also used HMT machine for machining operation. So I used drilling operation of 8 mm diameter drill bit. So now I would like to discuss about the results of my research. And if you have any questions, please put it in your chat box. I'll answer some questions. Here, the mechanical properties I have discussing here. How, yeah, here, these are the tensile properties of epoxy and FLF0, FLF1 and FLF2. So it is almost 176% is improved for FLF2. So that means 178 megapascal, whereas epoxy, pure epoxy is only have 64 megapascal. So in between, there are not significant differences. So it has only by using surface treated and as received, it has a little bit improvement. So if you see here, as received component of FLF0, so it is means there is no Ceylon treated. The second one, the green one is nothing but Ceylon treated. It is not Ceylon treated, yellow one. So it is not much unique difference between treated and non-treated, but there is significant difference between adding CBP, chitin. So if you see here 178, so this is not added, 142. So this is no chitin added. These two are chitin added, the FLF1 and FLF2. See, this is the same image of epoxy, pure epoxy. So it is a brittle fracture. So it is the curve. If you see here, there is no much elongation. It is have a sudden fracture. So it is a because of its brittle property. So it is a epoxy have more brittle nature. And this is after adding CBP. So it has, and also it is nothing but a betel nut fiber and leather. So if you can see the fiber pull out, you can find here by using this same image, and how this is about the addition of CBP. So how adhesion improvement because of the CBP and Ceylon chemical. So you can FLF0 as received and Ceylon treated from this respective picture. Fiber pull out and leather delamination were found in the composite when it is used as received reinforcement, whereas in treated specimen there is no considerable fiber pull out from the composite. So this is the main difference. So significantly there is no fiber pull out in this picture, in this image. There is some fiber coming out. So it is not treated by Ceylon. The matrix phase is isolated from a reinforcement phase because of the lack of adhesion between the fiber and the matrix. So after tensile testing, so this is the image of tensile specimen, and so this is the magnified microscopic image of that tensile specimen. You can find the fibers out here in this here there is some fibers you can visibly you can see here, this and this. So this is the center one is nothing but a leather. This first layer is nothing but a betel nut. The last layer is nothing but also betel nut. So in between it is bonding by the epoxy resin and CBP particle. And the flexural strength also have representing here by using graphical representation. It has a 100 time percentage is increased FLF2 comparatively epoxy. So it has more significant improvement in flexural strength also when it is adding CBP and Ceylon treated. So this is the specimen of flexural testing, and this is the magnified specimen of that flexural test. So flexural strength is mainly improved by using unmodified chitin particle, but it is greatly enhanced by using surface modified chitin particles, means Ceylon treated. It representing here it is nothing but Ceylon treated with biopolymer, that is nothing but CBP. And it is impact testing, ISOD impact testing, very low impact strength in epoxy, pure epoxy. And FL-F0 has unique difference, significant amount of improvement. Even though if you treat with Ceylon and CBP 1% is increased more, up to 7.4 joules. So because ISOD impact is measured by joules, it's energy. And this is the specimen after testing, ISOD impact testing. And this is the microscopic structure, and SEM fractography for surface modified FL-F2. So how the fiber pull out is here you can find, and there is some cracks between the fibers, so that is also represented. The some peaks are here, that is nothing but an interfacial crack of that fibers and matrix. So it is from the matrix, it's dislocated from the matrix. It is come out from the matrix. And these are the some significant points of ISOD fractographic analysis. It displays epoxy composite reinforced with arecanut fiber, goat leather with surface modifications, and there is little amount of failure untreated fiber reinforced epoxy composite dominated by the interfacial cracking. Yeah, and moreover, the delamination is another one of the important characteristics for this kind of goat leather and natural fiber composites, because this delamination, it very important characteristic. It is one of the drawback. If it is, you have to improve the delamination quality to enhance the property, to enhance the load carrying capacity of the polymer composite. And here hardness property, it is also not significant difference, because epoxy has more brittle. Usually brittle material has good hardness property, so there is no such difference in Ceylon treated or fiber or goat leather. There is no significant differences in this result of hardness testing. And this is the image of image of surface treated FL-F2. So how it is depositing chitin biopolymer, and it is spreading some places more and some places less. So even though if it is spreading all over the area properly by using advanced techniques for mixing, it also may be improved more mechanical properties. And this is the interlaminar shear strength. So there is no need to check epoxy, because there is no fiber and leather in that. So it is not possible to check interlaminar shear strength. Only it is property regarding the fiber. So FL-F0, FL-F1 and FL-F2 has some significant amount of improvement in ILSS property. It is about 6 megapascal for surface treated and CBP particle 1%. And these are the ILSS tested specimen, as I mentioned you. So how the interlaminar shear strength is withstand by the leather and beetle nut. So beetle nut have usually, leather has usually have more damping strength. So it withstand more than beetle nut. So beetle nut only cracks here. So there is no crack in the leather, goat leather. And these are the some statement of ILSS. So 33.6 megapascal is improved in the FLF2. Both beetle nut and fiber coat leather are treated with Ceylon treated, increase their values. Additionally, the incorporation of CPP into the resin increased the resin bonding strength and load bearing capacity. So it is 22% improved compared to FLF0 designation. That is nothing but a pure epoxy. So this is drop load impact. As I mentioned, certain velocity, you keep the specimen. If you release like a shooting of bullet, the same methodology, it keeping some distance and keeping some velocity. If you drop a mass, how it performs, how much energy it absorbs. So that is for epoxy, it has only 0.46 joule, and FLF2 and Ceylon treated is highest value. It is 16.3 joules. And it observed that epoxy resin have very low velocity, very low energy. It is nothing but 0.46, and this lesser energy absorption is because of reason absence of strengthening mechanism in resin. And composite fabricated with leather and fiber chitin has maximum impact of 16.3 joule. And the addition of fiber and leather with the chitin into the resin increased the energy absorption rate. And these are the some findings of from the image, SEM image. So this is the low velocity impact damage as received component, and low velocity impact damage surface treated. So there is no holes here, there is some holes here. And low velocity impact damage has received FLF2 rear side. So this is the front side, this is back side, this is front and back. So these are the top and bottom, you can say like top side and bottom side. So this is as received or nothing but non-treated. This is treated one, FLF2. Why I am only choosing FLF2? FLF2 only has more capacity. So only I chosen as FLF2 SEM analysis. So this is the fatigue behavior. And 924 count for epoxy, and FLF2 has 30,372 cycles, number of cycles, dynamic condition. Fatigue life count I have represented here. Fatigue life about 924 is indicated for the plain resin, and adding 30% of volume reinforcement leather plus fiber results 16,424 number of cycles, and 21,833 for surface treated FLF0. Yeah, here FLF0 surface treated. And the highest life cycle is the surface Ceylon treated with 1% CBP is 30,372 cycles. And this is the microscopic of fatigue behavior. So you can find here areca nut and chitin particles, chitin particles, and goat leather. The middle one is nothing but goat leather. And optical microscope, you can find the adhesion improvement fiber here. So there is some bonding in this place because of the Ceylon treatment. And this is about macroscopic image of the same fatigue behavior. So see here, it is the center layer. It's almost delaminated from the top layer. So it is completely detached from the leather and betel nut. So there is no connection between leather and betel nut. And so these are the findings of this picture. They represented in figure A and C. FLF0, FLF2 composite has received condition, and under repeated stress, the laminate delaminated, and there was a big bonding phenomena because of fatigue. And B and D are the other hand show that Ceylon treated FLF0 and FLF2 composite designation, and each laminate is firmly attached to the resin matrix, resulting better bonding and longer life, fatigue life. So here AC is no treated. This is treated. B and D are treated. So there is no much delamination between layers. And so these are some outcomes of fracture toughness. So unmodified and surface modified fracture toughness in terms of megapascal, and energy release megajoules per meter squared. The fracture toughness and energy released rate of epoxy resin measured 9.2 megapascal and 0.16 megajoules per meter square. And moreover, further addition of chitin into resin further improved fracture toughness and energy release rate. So there is some certain limitation. We cannot keep on chitin as 2%, 3%. I have observed 1% is the best performance. Maybe in further research, maybe you can increase 2%, 3%, and can also optimize the value of volume percentage of chitin, CBP. And the highest fracture toughness 84 megapascal and energy release rate is 0.84 megajoules per meter square in the noted in the FLF2 designation. And again, it is about semi-fructographic. There is some debris you can find here. The places that is notated made round, circled one, and interfacial crack. There is FLF0 specimen after fracture toughness. And this is about surface treated. This is as received, this is surface treated, FLF0. So there is no interfacial crack here, but here there is interfacial crack. And this is the specimen after fracture toughness, microscopic image. And there are some other analysis also done. This is based on dynamic condition of wear rate and coefficient of friction. So this is running as received and surface treated. So in as received, it has specific wear rate is more comparatively surface treated. Surface treated has less specific wear rate. So these are the some findings I have mentioned here. Drastic increase in durability is largely responsible for fiber elements' remarkable wear resistance, and a high level of frictional stability is maintained by the thickness of cellulose exterior surface and loading increased wear rate. Sorry, leading to wear rate. Because I don't know. I have 10 o'clock now here. 7:30, 8:30. Manuel sir, there is time, right? Is that time or time finished, sir?
Time is there, sir. You can proceed.
Okay. Yeah. So I think I have another 20 minutes, right?
Yes, sir. You can take 10 to 15 minutes.
Okay, fine. So these are the bond surface of SEM analysis after pin on disk. So this is the fiber element reduces wear volume by reducing the contact area with abrasion disk. And if you see here, SEM bond surface of Ceylon surface treated, there is wear direction shows here. So that means there is only one direction it shows as a wear surface. There is no overall wear because Ceylon treated is not completely spread over all the fiber elements. So maybe that is the another reason it is not evenly wear. So these are all the some significant difference or future scope of this research can make more improvement by a processing method. So these are the machining behavior. I haven't done many machining characteristics as I mentioned. For only metal based composites, they go for machining behaviors. Here it is only polymer composites, so it is not mandatory to do many analysis in terms of machining. Anyhow, I have done drilling process. Here there is some surface roughness and roundness value I have represented here. It is for unmodified and modified surface roughness I have represented. So there is no much difference of surface roughness. It is almost 0.5 micron difference to 1 micron level. And the roughness, if you see here, I have pictures. I will show you the pictures here. So this is surface roughness of 6 mm diameter drill bit, and this is for 10 mm diameter drill bit. So I have chosen two types of drilling, different hole size. So this is for 6 mm drill bit, and this is for same 6 mm drill bit with drilled FL. I think this is FL as surface treated. This is not surface treated. It is actually round surface because of the image position. It is like a flat. It is actually a hole. It is a hole. Here there is more delamination because of as received condition. This is Ceylon treated. There is no much delamination here in these surfaces. So it is actually, I typed it is wrongly. It is treated. And here In the same machining property, I have analyzed inner surfaces of drilled hole by 6 mm drill diameter and 10 mm hole diameter. So delamination obviously for 10 mm is more than 6 mm because of its bigger diameter, and it absorb more amount of force from the drilling machine. And you can see here drilling of that enlarged size of microscopic image. This is 1 mm magnification size. So there is some, yeah, I represent the next page about the points. You can see here it is not exact hole, but here it is good dimensional stability, and there is no edge damage, and there is more chips and debris here. So this is not treated, this is treated on. So A and B shows drilled hole morphology of FLF0 as received condition and Ceylon treated reinforced condition. Then second one, FLF0 composite, FLF0 composite are reason for excessive vibration of drill tool and poor bonding nature due to not surface treated. And FLF2 CD shows drilled holes with as received and Ceylon treated composite designation, same like FLF0 here, as received composite, excessive edge damage, FLF0. FLF0 means no CBP particles. It is only pure epoxy and 30% fiber leather volume percentage. So this is my conclusion. Addition of 30% of reinforcement boost the characteristics of mechanical performance, and adding 1% of volume CBP to FLF2 composite improves the mechanical property, adequate mechanical improvement, and it was noting that betel nut fiber and leather betel nut fiber Ceylon treated form outperformed betel nut fiber and betel nut FLF2 fiber as received form all composite categories. The wear properties of Ceylon treated fiber reinforced epoxy resin composites are produced improved wear performance and lesser coefficient of friction and specific wear rate. And also adding in addition the composite designation FLF2, that is nothing but 1% CBP. The fatigue life count is improved drastically, about 32,847, which comprises 1% of volume Ceylon treated and chitin added. It is the largest fatigue life of compared to other specimen designation. So according to the machining testing, Ceylon treated FLF2 has better dimensional quality or dimensional stability than other designation. The fatigue life count as received and surface treated reinforcements is 18,000 and 23,000 correspondingly for composite designation FLF0 are referred to by incorporating reinforcement of 30% volume, and FLF sequence with the Ceylon treated 30% volume and 1% CBP, that is nothing but a FLF2. This is nothing but FLF2 could be employed for improved outcomes and the waste goat leather may also used as primary reinforcement instead of fibers. So these are my conclusion of my results. And also the goat leather, why I chosen means it is a waste product, so it is disposable is very difficult. So by disposing or waste goat leather, I introduce to make a useful composite material. Thank you. Thank you. That's all of my presentation.
Thank you, sir.
Yeah. If you have any question, yeah.
Participants, any questions?
So there are, I expecting you to have a research collaboration with our university, and I have some research agency exclusively for aeronautical development. The new president of Indonesia has more interested in aeronautical and aviation material development, and also is the Doko Widodo, his name, is coming to India as a chief guest for uh, our Republic Day, 26th of January. So there are many opportunities here. People, you can apply here to many research agency. They exclusively giving opportunity for foreign faculties to conduct testing and doing experiment and doing some research as a short term, 2 months and 3 months like that. And they also providing some amount of funding also. So I encourage you to please apply such kind of agencies to improve your research capabilities. There is one BRIN agency. It is like our DRDO or HAL. They exclusively doing researches, especially in kind of sustainable materials and RPT, 3D printing and additive manufacturing. So you can also find, I will share materials to you. If you have any doubt, please contact my email. I will help you to how to apply and how to getting admission to do short-term research, such kind of agencies in foreign countries. And also there are many opportunities in Japan. And if you have unique research potential, definitely they select you to do postdoctoral in Japan. Many university they giving funding and as well as good sponsorship and scholarship. Yeah. Okay, sir. If you have any doubt,
In chat box, there is some questions.
yeah. Okay, sir.
Can I read it, sir? You can get it from that.
Yeah. So can these biocomposites replace traditional material in specific application? Yeah, yes, sir. Harish Bala, sir. You can replace some aircraft interior parts by means of biocomposites, because every certain duration they replacing the interior design and models in aircrafts, and also in automobile in interior design you can use this kind of materials. And also it is very convenient to dispose, and it is automatically degrade without affecting environment. And how do the mechanical properties of epoxy composite, how do the mechanical properties of epoxy composite vary with incorporation of other? The mechanical property I didn't get this question, sir. How do mechanical properties?
Properties of
Ah,
epoxy biocomposites vary with the incorporation of the other composition like
ah,
your research preparation, I think so. He mean that.
okay, okay. So
The
you mean,
compositions you taken that FL0, FL, FL1, 2, 3, like that.
yeah, yes, yes, yes.
How it is vary with this?
Actually, because of the bonding strength of the CBP and the Ceylon treated, so there is some chemical reaction taking place to enhance the toughness of the material. So normally the toughness is lesser compared to normal composite compared to my research. So because of that, the mechanical properties like tensile, flexural, all improved significantly than normal epoxy composites. How do material properties such as strength, stiffness, and toughness impact of design engineered system? How do material properties such as strength, stiffness?
He's asking about the importance of
Importance, sir. So the strength, if you take any kind of engineering components, the stiffness, as you mentioned here, the stiffness is more important quality. Using stiffness value, you can modify n number of qualities of uh, material. So in terms of body panel of automobile, and it will withstand more force while any accidents. So it should have more stiff than normal conventional plastic material. So it is not replacement of a pure metal-based composite. It is replacement of plastic-based material only. So it has adequate amount of improvement in strength compared to ordinary plastic materials. Okay, sir. Yeah. So I think I answered most of the questions. If you have any questions, please you can ask, sir. Yeah, I answered almost all questions.
any the questions from participant side.
So
I
you
hope
can
that
ask.
your presentations will reach enrichment of polymer composite using of composition of various epoxy composite, right? To understand about the mechanical properties as well as the technical of composites. Uh, I that sir, where will because you are away from our country as well as I thank for your valuable
Yeah,
share to research exposure. It is bio polymer composite materials like this.
yeah. Yeah, there are many opportunities, especially the biocomposite materials nowadays. If you have adequate knowledge in this kind of area, definitely you can find many research from foreign countries. So they are many of the foreign countries nowadays they moving to not too many chemical processing methods. They are not encouraging too much of chemical process because of environmental impact. So in order to make eco-friendly materials is most important nowadays. So this is the one of the trend going in overseas.
Professor, one more question is here.
Yeah, yeah, yes, okay.
Is it having a better strength to weight ratio compared to plastic?
Yeah, definitely, sir. It has a more strength than normal plastic material comparatively same size. Because if you take normal plastic material, it has less strength and as well as a low stiffness value. And if the same size and same weight ratio, if you go for fiber and reinforcement and matrix all together, it definitely increasing the strength of the product. So normally, the chemical bonding of the plastic. So it has more loosely compact molecules. So chemistry point of view, if you say like that, but in it is in composite material, the main advantage is the interconnection between the fiber and the matrix. So if the load is carried from the fiber reinforcement to matrix, so it is distributed evenly to all over the structure. So it has definitely it has more quality in terms of mechanical properties. Yes.
Professors and participants, please switch on your camera for the video session.
Okay, Dr. Shivakumar.